I'm going to talk about integrating data into the wiki, so it's very similar to what Samuel just presented. RDF is one way of one data source which might be relevant nowadays. Other data sources, typically in the commercial sector, are relational databases, and that's what I will be focusing on right now. So usually what you call legacy data. It is there, it's relevant, it's most of the time it's even the critical data of a company. It's in the database. If you do your help desk application or your customer relationship, it's in a relational database and it's crucial for your company. And typically you have many of those, and even more they are not really interlinked very much. So this is the term data siloing is what this is about. A wiki, on the other hand, is it's exactly the opposite. It is meant for data, it is meant for sharing information. And if you are using a semantic wiki, you can even share data. So this is like the two ends of the spectrum. And in companies, both things are relevant. So we won't be able to replace the database or the data silos or the infrastructure or the database. We won't replace this even with the best semantic wiki in the world. It won't happen. So the idea is, okay, why don't we make this data, which is crucial, available in the wiki to some extent, so that users can formulate queries against those databases, can browse through, can see what is there, and essentially use the wiki as a front end, among other things, to this relational data. And we have implemented a solution for this, and this has SMW Plus in our case on top, and it's using our triple store connector. In this case, it's using OntoBroker because OntoBroker provides the facility to access remote sources. In other words, in the wiki, you can do your annotations, you can do your markup, you can write your text as you do it now, and you can write queries against the data in the wiki in the same way that you do it nowadays. SMW Plus also provides a means for modeling ontologies and rules, and have these rules apply on the basic text. And with this component OntoBroker here, we can also have queries not only against the data coming from the wiki, but also against data coming from the database. This picture looks nice, but there is some effort involved in enabling this process, making this data available up there in the wiki. And this is more or less the workflow. It consists of a couple of steps, and it also requires one of our other tools that we provide, namely OntoStudio. OntoStudio is an ontology editor in the first place, but you can also do many other things essentially with ontologies. And the database is not an ontology, but it has some schema information, and you can think that there are automatic means to translate the database schemas into an ontology. I will show it in 1 minute. So then you have a kind of ontology representing the database, but in the wiki, your ontology, your categories and properties look very different to whatever is in the database. They might represent the same concepts, but they are different. They have different structure, they have different names, and so on. So that means we need to be able to map the data from the database into the wiki somehow. This is also done in OntoStudio. I will also give a small presentation about it in 1 minute. And then you can load this data. I think your battery is running low. Then once you have this mapping, you can connect these mappings into the wiki and then reuse the data there. I will show you how to represent the data coming from the database in Ask queries, in the ontology browser, so in all the tools that exist in SMW Plus. And then of course you can even change the schema and go back and then use the changed schema as a new mapping target in OntoStudio. I won't talk about it. Maybe a small side note, you can't change the original data in the wiki. although you can add annotations, you can find the additional annotation with your queries, but you can't write through the wiki and change the data here. That's not possible. And although I think that there are use cases for this. Where do you need to click?
The middle one.
The white one? Yeah. Okay. There are use cases, but there are also use cases for not allowing this. And I think they are the majority, to be honest. So this is like displaying the workflow. We have the clients and the SMW, and we have the original data here. So what I'm going to show is I will show how to automatically create an ontology from the database schema, and I will show how to translate one ontology into another one. In the morning, Anja presented R2R and Silk, and our mapping language is to translate one model into another one. We have a similar thing. We can create those mappings via drag and drop. You'll see this. And what happens essentially is we translate the vocabulary and structure from the database into the vocabulary and structure which is used by the wiki. And the query processing then works like this. SMW sends the query to the triple stock connector with OntoBroker. OntoBroker applies the mapping rules and those lifting rules, and on the way back it applies the mapping rules in the other direction to create facts or results in the vocabulary of the wiki. And the green things here represent the wiki vocabulary. Everything else is another vocabulary. So users of the wiki only see their vocabulary, their terms that they're familiar with. They don't care about the structure which is actually exists in the database. So let's go to the So what you see here is the screen capture of Onto Studio. On the left-hand side, you already see an ontology, which will become the target. This is, if you want, this can also be an exported ontology of your wiki. That means, okay, I will use this ontology on the left-hand side for mapping into. You don't, and this wizard here actually is accessing the specific database, Microsoft SQL database hosted on this server. It's called data in this case on this port and a certain user, and we are going to create an ontology automatically from this database. We can change some of the settings. So then we select the table owner. Data relation databases are structured hierarchically, so database owners own a couple of tables. And then we select a couple of tables that we want to lift, to translate into an ontology. For each of those tables, we select or look at the keys, because the keys will determine the object identifiers, right? In RDF and in Semantic Wiki, we have objects with properties. This, of course, doesn't exist in a relational database, but we have to translate it. And what's the result of this wizard is we'll get an ontology where one class represents one table, like the cars, prices, and vendors over here, and one column is represented as a property. Some of those properties, and they have appropriate domain and range definitions, appropriate cardinality restrictions that can all be extracted from the database. So in this example, you see that the prices class as a car, as a price, and the vendor, meaning the vendor sells a certain car for a certain price. And you can see that the car, price, and vendor here are strings and doubles, but actually the price should refer to the other object, which is the render. The price should refer to the car, which is an object. So that means from the database lifting algorithm, we also get FK properties. FK stands for foreign key. That means we also have a pointer from an object of type price to an object of the type car. So that's how this ontology is created automatically. And to prove, maybe I didn't say this, we don't only extract the ontology, we also create rules which, when we query this ontology, will go down into the database and retrieve the facts from there according to this ontological schema. So I think this is going to connect. Yeah, we can create a query asking for all instances of the class car. So we are not formulating SQL queries against the database, we're formulating queries in our language or using our tools, saying, okay, find me all cars and also give me the company and the type and the name. And this is the result. We don't have any instances in the ontology. These facts come directly from the database. So that means we lift the facts onto the ontological level. So this is the first step. Any questions? Yeah.
What kind of RDB analysis system is it? Only SQL Server, or you have a...
No, we also support Oracle and MySQL. So maybe more, but I know that these are there. Oh, there's DB2. So I don't know exactly, but probably you'll find what you need. So So what I just showed now, this step, getting from a database to an ontology. So maybe you can say we're just defining a mediation level. Saying, okay, it doesn't matter what data source we're accessing, we put them all on one level so that they can better talk to each other and that they are compatible at least from the technical point of view. Not yet on the conceptual point of view. So once slowly mapping. So what we need to do now is we need to map the schema that we got from the database and the lifted one, the one that we lifted, to the schema or the terminology that is used in the wiki. And this is done by mapping. We drag the wiki ontology on the right-hand side and say this is the target of our mappings, and the database ontology, we drag it on the left-hand side of our mapping tool and say this is the source of our mapping, and then we can draw lines between classes on the left-hand side and the classes on the right-hand side. We can say the cars class in the database ontology, and then meaning actually the cars enabled in the database, represents or is equivalent to the car category in our wiki. We just draw this line and rules will be generated which will be executed when we do queries later. And we can
manually draw the line, or you can by default just draw the line, draw all the lines automatically. And
no, there's no automatic process. Everything must be done manually here.
If I have one go, I have to draw one line.
Yes. This is the standard ontology mapping effort. As Anja said in the morning, the precision is about 60%, and it really depends on the domain, how many examples you have. So automatic ontology alignment is an unsolved research task. So you should not expect to do like this and everything will work. So, and yeah. I'm sorry for that. Okay, we can also, of course, we can also associate property values, and to read the lines at the bottom say, whatever. Can you read this actually? I can't. I'm sorry. Okay, then let me try to read it to you. Okay, so this says this is the cars table. actually, and this is the car category in the wiki. And this line says, whenever I have an instance of the cars table, it will become an instance of the car category in the wiki. And this says the name of this car will become the value of the has name property in the wiki, and this is doing the same thing for type.
Michael, that is only run in Auto Studio or also in YouTube?
No, this is not compatible with any. And of course, relations are also relevant. We cannot only assign atomic literal values to objects in the wiki. You also must create links between objects. This is done via the foreign key relation here. And the tool supported if you want to associate a property with another property, it says, okay, you probably also want to associate the associated classes with each other, so there's some help in doing this. So I think this is sufficient. You can also formulate filters that certain mappings only apply if a certain condition is fulfilled. So more or less what R2R can do.
On the side, there is the ontology wiki, right?
Yes.
I'm not able to create a property and build a rule to say it maps to some columns.
Yes. Yeah. So actually, you're free in creating the wiki ontology even here, because the next step that I'm going to do is to import this ontology, because this ontology is not only the categories and properties, it's also the lifting rules. So the lifting rules must be deployed into the wiki so that it can be used for query answering.
Okay, so I can drive one from the database directly to the ontology of the wiki,
Yeah.
and also I can create something new and
Yes.
have a rule to map.
Exactly. Because the next step is probably... So now I'm going to the wiki, and this is how the wiki looks right now. So there is countries with a couple of subclasses and instances. There are entities which are the basic SMW class things, person, project, task, and user. So nothing that we talked about here. Maybe I can do a small side note for Samuel. This is how our ontologies look like. When I load the countries ontologies from FAO, it looks something like this. So we use the slash instead of the colon for separating the namespace from the local value. And we also have mapping tables which associate such a prefix with a long URI.
So, if you say mapping tables, is it some kind of database stuff, or is it in wiki, or how do you represent it?
It's in the database, but there is a special page, or there's a page in the wiki where you can edit this. Yes.
Right.
And we also have an ontology URI annotation, but this is missing if the concrete mapping can be computed based on the namespace. So it's not always there, only if necessary.
Okay.
And I can also show you that these annotation, that the imported ontology actually is turned into an annotation, because our faceted search, for example, only works on whatever is in the wiki, doesn't consider the triple score at all right now. So I can go here and look for all self-governed countries, meaning countries which have their own authority. I can look at all the countries which are in Africa, for example. So I can drill down using the data which is annotated in the page. And then maybe I can just look for those countries which have been founded between 92 and 94. So we have Eritrea and Ethiopia here, and all those things are annotations in the wiki page.
So with that annotations, you mean like plain RDF triples.
Yes.
Right.
They, plain SMW annotation.
Oh, yeah, okay, right.
Which
Yeah,
then can be interpreted and are interpreted as RDF triple.
Yeah.
And we have a kind of template for importing instances. So this is Eritrea has a longitude of 32.9 kilometers. The real annotation.
Right.
But this is just a side note. What I wanted to show actually was that the ontology that we saw in the ontology editor is not here yet, but I can import this one. And this is this one. I install it using the deployment framework, saying, okay, I have an ontology, please go and load this ontology into the wiki. And loading an ontology into the wiki actually means create pages for all categories, properties, instances, and add those annotations as I've just shown. Okay, ontology has been imported successfully. Let me reload the ontology browser. And now you can see that we have products, revenue, sales, vendors, and I hope we also have cars somewhere. Where is it? Oh, too bad, there are no instances. Oh, what happened? The reason is we only deployed the right-hand side. We didn't tell the system yet that there are those database listings and the mappings should go to, should get them. So, and in order to do this, we must tell the system, okay, this is the database ontology, this is the here are the rules to access the database, and we do this, and this is a feature, as I said, of the triple store connector. So we put this database ontology, which is we automatically generated, put it in a special folder, autoload folder of the triple store connector, restart the triple store connector, and then it gets picked up. And the data should become available to the wiki tool.
The data will be copied into triple stores in wiki. This data will be copied into
No.
the
The original data will stay in the original source. It will still be in the data.
Okay. So only way of query is for the data
Yes.
to access.
What I'm loading into the triple store right now are the lifting rules, which translate database data into RDF triples, sort of, and the schema that represents the database. There's no single fact in this lifted data.
I can see there's a lot of nice user interface to it, but in principle, it's also very different than what R2R does.
R2R doesn't do it at query time. That's actually a very good question. R2R is an ETL pipeline where you click, translate everything, and create the RDF triples, and then they could be stored in the triple tool. And actually, in the neural-based settings, we have done it. But in enterprise settings, where you have live data, as I said, this is applicable, but this is useful sometimes. Sometimes it's more useful to don't redundantly copy the data over to some other place, but to keep it where it is, so that other systems can still access it, and you additionally make it available to me.
But it looks like the price tag, I think, of 35,000 euros today. Something
Maybe,
like
yeah.
that. So it's really geared towards enterprise applications.
No, I would say so.
But if you have a small company, then you will have a different price tag which starts much earlier, much lower.
Oh, I didn't get lower prices.
Yeah, we have a new price list.
Okay, that's very interesting.
Okay, so I
But
just...
I think that's really relevant for people to know that there's a component in this which is really relevant for commercial applications.
It is.
I mean, this is, and also for biology applications. I mean, The
No.
Allen Brain Atlas has terabytes of data.
I mean-
We're not gonna copy all that into SMW.
I didn't mean
You've
the,
got to access it on the fly.
I didn't mean the technical aspect, but the
Okay.
financial aspect.
Oh, yeah.
Okay, so now these links are established and the rules can be applied. So when I go to the OntoBroker browser now, I click on the car category. I'll see a lot of stuff in the instances table now, but this really doesn't look good. It's even worse than the URIs that Samuel showed earlier. They are also URIs. We already shortened them, but they are unique identifiers created by the lifting rules from database rows. So they don't look good, but we have means to cope with them. So let me show you that we can also access this data in the query interface, and that means also you can write your ask queries against them. I'm sorry for this CSS hiccup here. So I'm creating a query asking for all cars. And immediately you'll see this not so nice list of identifiers. But let me ask for the name of this car. And the table gets updated automatically. Then let me ask for the group. Type. And I think manufacturer was the last property. Actually, autocomplete is quite good. It proposes exactly those properties which are applicable to this category class here. Manufacturer. Then I can just say minus here, right? To get rid of this annoying URI. So nevertheless, we can grab this query and put it on some page. Maybe we just put it on the main page of the wiki. Copy it here and see whether it really works, even if it's in line. Yay, the table is there. So, but there's no way to click, right? And actually the objects are there and they are virtually mirrored in the wiki as well. So let me try to show you how we can make access to those objects. In order to hide those long unreadable URIs, we have implemented a new query printer that we call Fancy Table, which allows to replace awkward-looking links or actually any property with another property. And this goes like this. We say, okay, you want to replace the main label with something else. Maybe let's take the main.
You can use that format for anything in the query system. I mean the query screen.
No, this works only for exactly this output form. You're talking about the replace mechanism, right?
Yeah.
No, this works. This is a special feature of Fancy Table.
Okay. Yeah, and I understand the fancy table you can use anywhere or only for.
No, this works for all other things.
There's somebody special.
Yeah. So, but here is it actually necessary because your eyes look like this and no one wants to see them. So what we have now is we have replaced the awkward-looking labels with better-looking names. But as you can see at the bottom here, the link actually goes to the original URI within the wiki. So when I click here, I'm redirected to an empty page, essentially. because there is no wiki text there, but in the triple score we know that there is some information about this object. And this page actually is not so empty because it says, okay, I didn't find a wiki page for this, but I found it in the triple store, and here's the data that I found. So this is automatically, this is a generic template saying, okay, the object that you clicked has a couple of properties. It has a manufacturer, a name, a type, and it belongs to a car and product classes.
You say, sorry, is this a special page? I don't see the URL.
No, it's not a special page, it's a normal page.
Okay.
And
but you somehow hook in and take care of it.
Exactly. So we have a hook here saying, okay, if the page is empty and we find something in the triple store about it, we'll display this. And this actually is generated from a normal MediaWiki template, which you can configure. Yeah. And the configuration is even smarter. You can say, whenever you find something which is a car, then use this template. Whenever you find something which is a person, then use that template. This is the most generic one. It displays more or less all the triples where this page is a subject of, and all the triples where this subject is where this page is an object of. So this is very generic, and you can see, and then you can actually go here and browse through the knowledge base and navigate from one object to the other.
Yeah. This page, this is outside of the database. This is added by someone else.
Yeah, this page ships with SMW Halo, or no, this page does not exist.
Not exist.
So, but the template which generates this page is delivered with SMW.
The data is from the triple store.
The data is from triple store. Who put the data into the triple store? It's not from database, right?
No, it is from the database. It is from the database. So everything that you see here, right, this, what you see here,
Yes.
and what you see here, they are actually subject, predicate, Audi Quattro. This is what you should read. And this says Audi Quattro has a manufacturer Audi, it has a name, all round something, it's a type, just run. These facts come from the database, and they go through this process at query answering time. So what's behind this page is essentially a query against the system. The system goes to the database and fetches the data and returns the value and populates those small tables. So this process here happens every time when such a page is referenced.
So you could say it's a way to solve the problem that when you specify a property, if you don't create the page, you still want to take care of that.
I want to see something, yeah, at least. Yeah. But objects which come from the database or from a remote source, which is not the wiki itself, they are somehow in between. They're not real wiki pages, but they also don't not exist. They are somewhere that at least we have data about them. And this is this generic page handling is our way of coping with this intermediate state. I know this doesn't look nice, but it contains all the information.
How can you verify? So when the page does not exist, you click that, you find this page. This page is actually show the information, like duplicated. You just presented the information in the database in a page.
Yeah, this is a query. This is a lot of a query. So maybe it helps if I show you I can even create this article. So I will create an article now, which will look exactly like this one, but then it will become a real wiki page. The link is not read anymore. It will become
If it's from a wiki page, that will be static. The data will be static. If you query from database, if you change this data, then your page will be different.
No, it won't be static because it will still be query results. So this is the wiki table, and this is actually asking for find me everything where this object that I'm talking about right now is the subject of a triple, and then give me the property and the object, and render this as a table. So we put the query in the page, and this query goes to the just display. But you can also add data on this page if you have additional properties. So if you formulate a query, both information will show.
But I guess the confusing thing is that when you add something to a page, then it will actually go down to the RDF store. I mean, the RDF triple store will also be updated, and then you query it back. So
No, it's not the case.
it's not.
No, the triple store will be updated.
Yeah, exactly.
But not the database.
So, okay. Oh, okay. Right.
You don't pull it into the triple.
No.
So you have.
You only send it through.
So whenever we make an edit, if there's an SMW annotation somewhere, it will be stored in this layer. Right? This is our triple store. And the data from the database is only accessed when queries require it. So they won't be copied. The query always goes down to the database. It's like a read-through, does it exist? I don't know. So it's reading through the triple store connector layer, but there's no write-through to this layer. Everything that you write lands here. Everything that you read is the union of this and this.
I think I was confused about this because you have the MediaWiki database as well.
Yeah.
So here you have three databases: the triple store,
Okay.
the MediaWiki database, and the external one.
Yeah, right. So triple store connector is like the triple store in the SMW 1.6, the 1.6 sense is a duplicate of MySQL database.
So it's a real broker. In this case, it's a real broker. It's really
In this case, yeah, actually this is why it has this name, because it can do this. Yeah. So,
But normally
But we-
it just functions as a store, so not as a
And-
broker.
we do our query answering from the triple store connector, not from MySQL, because we apply rules and other things which are not immediately applicable to MySQL. That's why we duplicate it. And I think this was more or less everything that I wanted to show.
Just to be clear, the OntoBroker, the other thing OntoBroker is doing is applying those lifting rules on the fly,
Yeah.
right, to translate between the two ontologies.
Yeah, the lifting rules and the mapping rules.
And the mapping rules,
Yes.
right. That's why it's not just a pass-through, because you have to actively move
Yeah.
everything from the database ontology into the wiki ontology.
Yeah, you're right.
Michael,
Yes, please.
could you please again show how you browse through the data in the triple store? Because that is quite interesting, I think. Because I will give a presentation of a semantic web browser, so how to browse the semantic web.
So you can either use the structure here and click on one of those things here. Right. All those pages only virtually exist, right? There are only queries here. And the queries will find other objects which only are represented by virtual pages. So that's how you can navigate.
So
But
basically,
in this case, actually, we should not So this is a very generic interface, right? It's just saying, okay, this page is used in those 1, 2, 3, 4, 5, 6, 7 triples. And here it's the subject, and here is the object.
and could you now create one of these red links on the right side? So if you click on it and then you create it, then if you go on this page afterwards again, then it should be should provide the right link to that wiki page.
It's the
So you
same.
can annotate it.
It's
you
the
can
same
write
link.
on it.
Okay. Just create.
Because then it is kind of useful to show these red links, because you can at least say, I want to talk about this instance which is in the database or in the triples.
Yeah, that's why we do it, but the names are obvious. So I just save this page, this one.
But once you create the real page, you can add text on it or other.
And you can give it another name, a more human readable name.
No,
No? Why not?
because this is the idea of the thing.
But
It's
you
the
could
identifier.
create a wiki page and annotate it with the URI that is
Okay.
used in the triple store. And then you could show a proper human readable name.
You're right.
How are you?
I have to think about it. Let
visualizations, I think that's a good one to do.
But on the other hand, we're talking about instance data, right? And databases usually have lots of rows. And for only very few you want, where you can create readable data, which is unique, which still is unique. But in general, I agree with you.
How complicated data ontology can be? Like if I have a database, I have a master table, I have detail table, I have detail table, the detail table, and it can go many, many layers. And in the ontology, it can be really, it can have a category, subcategory.
Yes, of course.
Yes. No limitation.
But databases typically don't have this subclass notion. Their model is different.
Yeah.
Of course, there are.
And this reform keeping it can be, and that would be all categories. All the tables.
If you map to a subclass, everything that you map into the subclass will also become an instance of the superclass. But I must also admit that the mapping GUI that we have cannot support all possible mappings between ontologies. But you can formulate rules which do this more advanced mappings which are necessary.
Okay. When you run your queries, can you write a query to join two tables? And that means it get data from two categories.
Yes. Usually
Join by some of property and show it in one.
one object. You can merge multiple classes, even multiple rows from different databases into one object. But you must identify that they are the same. This is similar to what Silk does. It applies some rules, saying, okay, this object in this database is the same as that object in that database, and I want to merge them, and I want those two properties from there, and those two properties from there, and want to have them all assigned to one object. That's possible, but doesn't come for free.
Okay. And sorry, when you got this ontology from database to wiki, you link to database. Do you also link to a model tool like person? And when you define the interval to get the ontology of
DDL.
Okay.
modeling tool?
No, we don't. But I think it's a good idea. I mean, we don't need to automatically create ontology. We just translate the ER model in.
There's an Apache nice project that creates DDLs from databases.
Okay. So this is not my main area of know-how, but I think that's a good idea to support those things. And actually, I'm not really done because I have the summary and outlook slide, which somewhere. And I think I don't need to summarize what I did except for the line in green, which says we did all this. We did the lifting and the mapping in order to support the wiki users so that they can use one vocabulary. So this is like the main goal of this whole effort. It's easy to say, okay, here's the database. You can send SQL statements to there. No one will do it in the wiki context, most probably. The funny thing, in the Sparkle context, people seem to like that, to use different vocabularies from different sources. So I don't know where this comes from, but this is, nevertheless, this happens. But not all wiki users are aware of the different vocabularies and different endpoints. So we are currently working on supporting the same strategy of lifting and mapping, not only for relational databases, but also for Sparkle endpoints. So, and the approach that we are taking there is to query the endpoint, try to retrieve the schema from there. It doesn't always exist. Sometimes there are only facts. That means it's hard to extract the schema from there. And this extracted schema also again comes with lifting rules, which later at query time go to the Sparkle endpoint, fetch some data, and create the results for the query. So the same lifting and mapping that I showed before is also going to work for Sparkle endpoints. We are currently evaluating whether this is really applicable on a broad range of endpoints. But And I'm pretty sure it won't scale as much as databases do, because they are really remote and there's no way of, it's really hard to optimize Sparkle queries which are constructed from small pieces. But this is the current goal. Have the same architecture, but now support Sparkle endpoints like EBP. Okay, that's it. Any more questions? I think you have.
Is there any possibility to define such little mapping rules for other triple stores than OntoBroker, or is it new feature of OntoBroker?
Good question. Of course you can formulate mappings, but your triple store must support them. And I'm not aware of any other triple store that can support rules or something which accesses other sources.
Another question in comparison with, for example, the web service feature of SMWCon. The data there, is it also stored in the triple store, or because you can query it also, or is it stored anywhere else?
So the web service feature, there's a possibility to triplify, in fact. That means it's stored in the middle layer here.
Okay.
Yes. And the web service import is part of the data import extension, where you can also create pages. That means you don't store it in the triple store, you store it in the page, and then indirectly the annotations are stored in the triple store. Yes?
Tomorrow morning we have seen approaches to make additional data available in triple stores. But the question I have is there a way around? When you have when you think of a good triple store and you have a less innovative partner that still has some XML import, is there a way to go back from the triple store to the traditional XML file, or are there two quality styles?
RDF is XML? No, I don't really understand the question.
Well, you have, for example, a BME cat, XML file, you don't follow it.
Not by heart, but I know what it is.
Well, that is legal. And it's, I'm thinking of a scenario that put data maybe in the triple store, but they are cool guys, they don't have a triple store, and the application doesn't support it. So is there a way to go back from the triple store to a traditional BME file?
I'm not aware of tools, but you can write Sparkle queries which populate templates which then look like XML files. It should not be too hard. If the data is compatible, this is the main case, right? Everything else is only work.
For me, a month a day.
I don't know how complex BME can is. I can't tell.
Okay.
Anything else?
Is this open? Oh, sorry.
I think this is the same
I
question.
think it's the same question.
And the answer is no. No, the answer is wait. The answer is yes and no, because it's not the same question. It is available. You can purchase and use it, but it's not open source. It's part of the main functionality comes with this component, which is the main asset of OntoBroker. Costs something.
It only costs 4,000 euro, right?
Don't ask me about the price.
Is it now?
Think of a value, right?
I want to try it. Do you have a free file? At least it's
Yeah, actually, this should
Please
be
come to
triple
me afterwards
TSC
and
professional, you're right.
talk about the prices.
Okay.
Yeah, do you have trial versions?
No.
No.
You can easily
If you really ask me, you
I
get
can
1
have
month.
someone design this for me without doing anything.
Yeah, you
Yes
can.
and no.
You can actually get a version of OntoBroker as community edition. This is more or less a kind of like an evaluation license. So this is what you get for free, but you might not expect any support or something for setting it up, because it need some engineering for building, for example, the mapping rules. But you can get that, of course, and also you can get a 1 month evaluation license for OntoStudio. This would give you the chance to try it out by yourself without having an investment. But don't forget, this software is industry-grade software. There are people working hard on it to make that ready, so there are patents registered on this software. So this is the reason why it's not open source software. If you want to try it out, because you have such a limited budget or another product, then probably the E2R open source software would be an alternative. But then you would see where the difference is between an industry-grade software and something you need to probably compile and et cetera, need to run. Well,
And it's not a lot clearer.
It's not a lot clearer.
Yes.
And that's a big difference.
Yeah, of course. I mean, industries need something that is supported and so on.
Yeah.
So it's really clear. But just, I mean, trial versions, I think it's important because it can be very hard to know where the limits are if you want. In practice, like for your own problem, you need to explore things and see.
so we have a trial version, but we have been quite cautious in the past about giving out trial versions of it. You need even to undersign a bit of paperwork, because if it's not properly set up, then you might tell, all right, OntoBroker, what a heap of crap I got there. But the reason is that bring it to life, that the mapping rules is you need some engineering, ontology engineering.
Actually, you will train consultants.
So I don't know what's next. Oh, there's one more question.
Are there plans to show write back to the database? For example, yeah?
No, explicitly not.
Okay.
Yes, thank you.